YouTube? It's your boy JOSHABRAHAM, and we are looking into organic chemistry. What? Nope. These are the first questions. That's the glucose. Twelfth question. Now I'm looking for 7. 9. Not even numbers. Yeah, that's this one. So we're right before that. Okay, 8. Now this should be 7. And substance A, strong bond, peak, strong broad, peak at 30, 40, carboxyl group, carboxylic acid. Strong sharp peak at 1700. Carbon oxygen double bond. The OH and C double one O the most. What are they? What is this handwriting? Most structure. Probable structure? That could be the wording. Carboxylic acid. B. IRA. The second one is NMR. H1 NMR spectrum. NMR spectroscopy, organic chemistry, stri. Dude, look at how many ads does a new account have. This video. Let me. I'll be right back. Let me just wash my hands. It's really fucking cold. We are here. There was something I was thinking I should get. Was it the leg? No. My tablet? Shiesty. Yup. Because my hair is fucking mess.
We're going to talk about the basics of NMR spectroscopy. NMR spectroscopy
Daniel
is
Carnero.
useful for identifying the
Yo, what's up, man? How you doing? I really appreciate you for checking out the stream. I gotta say, it's been a long time. Can you hear me? I believe the mic is on. Yeah. And I was looking into NMR spectroscopy because I gotta just. I had an exam. Oh, fuck you know.
framework of an organic compound.
Time
Now,
for some
it only works with
Undertale.
certain nuclei.
You know what? It's been some time. So let's do 15 minutes of Undertale. Yeah, I can hear. That is good. Should I change the camera? Two big ones? Just for the Undertale part, maybe? Maybe. Just. The chat is kind of delayed. Yeah, the problem is every time I start the stream, the streaming platform just goes for the normal latency. And yep, that's the problem. Okay, last time I played, I do remember it was a boss fight. Hey Siri, set a timer for 15 minutes.
15 minutes, counting down.
No more running away. Here I... Oh. Okay, so... En guarde. Please. Plead. You told Undyne you didn't want to fight, but nothing happened. As long as you're green, you can't escape unless you learn to face danger head on. You won't last a second against me, okay? Bleed. Told me you fight, but nothing happened. Okay, not bad. Then how about this? Plead. For years, we have dreamed of a happy ending. Smells like sushi. What? You forgot to save after defeating Undyne. No, I did not save to defeat Undyne. Now sunlight is just within our reach. Oh shit. Wait. Please. What happened? I won't let you snatch. Okay. I'm still green. Enough warming up. Oh, you can't just transition. Plead. Just leave me alone, bro. So from what I heard last time, if I try to run away, Plead. The attacks become a little bit less extreme, okay. But even if you could beat me, go ahead. Just because you can. Grab apple. No human has ever made it past Asgore. Can I still run away? Nope. You need to run away with the flee button. There's no flee. Your attacks become less extreme. Honestly, killing you now is an act of honesty. CT? Speed boost though. What? No. Oh yeah. Stop being so damn resilient. I don't want to attack. Leave me alone. I just want to go home. Oh. I just want to go home. Run. No. You can't do this. Loud broadcast. You can. What? Oh, what the? What was that? Please. You told the Undyne you didn't want to fight, but nothing happened. Whoa! bandage? Nope. But I'm determined too. No way. No way. Crab apple is healing at him. I know, but I can't just keep on using it. No way, I smell like sushi. That's my last crab apple. Lead. I'm not fighting. I'm a man of peace. Right now. Lead. Oh, chill, bro. No. Lead. Die already. Yeah, I mean, you could just leave me alone. What the? Stick? Can I run away? Run. I guess that's it. I don't have shit. Flee. Welcome to hotel. Hey, wait. Hey, what's up? I was just thinking, you, me, and Alain should all hang out sometime. I'm almost there. I got it. After you hang out with me, let's meet up at your house. I think you would make great pals. Like, run. No. Whoa, dude, just wake up, bro. Okay. Come on. Chill, though. Chill. Armor so hot, but I can't give up. You should give up, goddammit. Oh, she dead? Maybe I could give her some water. It's a water cooler. Take a cup of water. Yes. Take a cup of water. Throw. Give Enda in the water. Yes. Little bit of water. You could. I won. You know, I'm a man of peace. What can I say? What's happening? Okay. Those yellow teeth. Now, you could have at least tagged me. Don't forget to save, yeah? Okay, I did skip the boss. Can I talk to Sans? Nope. Sans ain't here. Oh. Wait. Okay. I was thirsty, so I came over from the waterfall to get a drink. Well, I don't care. We got the save button, Seeing such a strange laboratory in a place like this. You're filled with determination. Save. What do we have here? Sorry, Undyne like told us there was totally a human in the area. So like us royal guards are blocking off the elevators for now. Yeah. Even if the elevators aren't working anyway, we'll do our best, Mrs. Undyne. So she's up there. Oh, a lab. You can't hang out with her in neutral, only in pacifist. Okay, so I should not kill anyone. I think I'm in a neutral. Don't tell me we're a lab experiment. It's you. We're a lab. It's too dark to see near the walls. I don't think it's that dark. It's too dark to see near the walls. Okay. That's the falling guy? No? Nope. Fight! Oh. My god, I didn't expect you to show up so soon. I haven't showered, I'm barely dressed, it's all messy and it's okay, okay, calm down. Let's talk. Hiya. I'm Dr. Alpais. I'm Ascor's royal scientist. But I'm not one of the bad guys. I mean, okay. Actually, since you stepped out of the ruins, I have been observing your journey through my console. Your fights, your friendships, everything. I was originally going to stop you, but watching someone on screen really makes you root for them. So now I want to help you. It's Alpais. She'll help you for the rest of the game. Okay. That's a good character, I believe. Using my knowledge, I can easily guide you through Hotland. I know a way right to Asgor's castle, no problem. Well, actually, there's just a tiny issue. A long time ago, I made a robot named Metaton. Originally, I built him to be an entertainment robot. Huh. You know, like a robotic TV star or something. Anyway, I recently decided to make him more useful. You know, just some small practical adjustments like anti-human combat features, okay? Of course, when I saw you coming, I immediately decided I have to remove those features. Unfortunately, I may have made a teensy mistake while doing so, and now he's an unstoppable killing machine. That's good. That's good. With the thirst for human blood. But hopefully we won't run into him. Hopefully. Okay. Did you hear something? No. No. What kind of bullshit did you cook up? Oh yes. Welcome, beauties, to today's quiz show. Oh boy, I can already tell it's gonna be a great show. Everyone give a big hand for our wonderful contestants. Okay? Never played before, gorgeous? No problem, it's simple. There's only one rule: answer correctly. I'm good at answering questions, or you die. Okay, that's the robot. Act. 15 minutes? Okay. Check. Defense 255, okay. Let's start with an easy one. What's the price for answering correctly? Mercy? I can go? You pushed wrong, okay. Can I cry? Here's the terrific price. What's the king's full name? It's Asgore. Correct. What a terrific answer, dude. That's the king. You can't just should I fight? What are robots made of? Metal and magic? The quiz show continues. Here's another easy one for you. Two trains, train A, train B simultaneously depart station A and B, station A. No! How much longer until the train pass each other? How many files are in this jar? I don't know. I think that's not random. It's just no matter where you go, it's correct. Let's play memory game. What monster is this? It's a frog? Frogget? No? Not a frogget. But you can die in this fight. Looks like I'm dying. But can you get this one? Would you smooch a ghost? Yeah? The quiz show continues. Just kill me. How many letters? No. Oh, I can just get out of here. What? It's a snail flitter on she's wanted, so... Alpies. You aren't helping our contestant, are you? Oh, you should have told me. I'll ask a question, you'll be sure to know the answer. Who does Alpi have a crush on? Asgore? I don't know. Simple. To impress Mr. Asgore Demure, of course. I respect that it's the king, right? Or as Alpies calls him, Mr. Dreamy. Those strong arms. That lustrous beard, okay. Like all those who create weapons. She craves the tender embrace of a burly man. Can she truly be blamed? Nope. Well. With Dr. Alfie's helping you, the show has no dramatic tension. We can go on like this, but this was just the pilot episode. Next up, more drama, more romance, more bloodshed. Until next time, darling. That's it. That's it. Well, that was certainly something. I think that's it for today. Can I... Wait. Let me give you my phone number. Then maybe if you need help, I could... Yeah. Where'd you get that phone? It's ancient. It doesn't even have texting. Wait a second, please. Here, I upgraded it for you. You can do texting, items, it's got a keychain. It's got a keychain? Fun fact, King Asgore is Toriel's ex-husband. Is Toriel the woman that the the woman that took care of us at the first part? Now we're officially friends. No, no, get me out of here. I'm going to the bathroom. Yeah, you should. Well, that took a good turn, and I'm happy that I didn't kill Undyne. I mean, if I had to, it's gonna be a long run, so this ending was much better. Seeing such a strange laboratory in a place like this, you're filled with determination. Save. Well, that's it for today. I really appreciate Undertale, and I'm at level 7. Toriel is the goat lady from the ruins. Okay, yeah. I believe I did not kill that woman. Please, don't tell me that. Well, yeah, this episode was pretty good. I should say that. So if I remember, what was the last part? I got a phone. I think I need to explore more for the game. Please tell me. I will see Toriel later. Because I don't want to be that guy. I don't want to be. Well, Daniel Carnero, I really appreciate you for checking out the stream.
And that is nuclei, either with an odd number of protons or an odd number of neutrons. So let me give you some examples. So nuclei such as hydrogen, carbon 13, nitrogen 15, fluorine 19, and phosphorus 31. These nuclei either have an odd number of protons or an odd number of neutrons, because as you can see, the mass number are all odd. And the mass number is the sum of the protons and the neutrons. So let's take a look at carbon 13.
Wait. NMR. Toriel only shows up again in the pacifist route. So in neutral route, she doesn't show up again after the ruins, even if you spare her. Okay, so that actually made me feel better, because that means I did not kill that woman. I did not do that. I did not. I did not know that you could spare. Okay, so I'm really excited to meet Asgore now. Not gonna lie.
So carbon 13 can work with NMR spectroscopy, but carbon 12 cannot. Every atom of carbon has an atomic number of 6, and as we recall, the atomic number represents the number of protons. So carbon 13 has 6 protons and 7 neutrons. The mass number 13 is the sum of the protons and the neutrons. Carbon 12 has 6 protons and 6 neutrons. Carbon 12 does not have an odd number of protons, nor does it have an odd number of neutrons. So carbon 12 does not have a property called spin. Therefore,
Property called?
12 does not have a property called spin.
Spin.
Its nuclei will not be, you can't use it in NMR spectroscopy. Carbon 13 has an odd number of neutrons, so therefore you can use carbon 13 in NMR spectroscopy. Now before we go into carbon 13 NMR, typically you'll learn proton NMR or H NMR. Now, hydrogen has a mass of 1. This is the most common form of hydrogen. There are isotopes of hydrogen like deuterium and tritium, but we're going to talk about this particular hydrogen atom. It has only 1 proton, no neutrons. So you can think of the hydrogen atom, or the hydrogen nuclei rather, as a proton. And a proton has a positive charge. And it has a property called spin. And if you studied physics, you know that a moving charge creates its own magnetic field. So you can think of the protons as generating their own magnetic field. Now, let's say if we have a sample of protons. So these protons, their magnetic field will have a random orientation. But what happens if we take these protons and put it in an applied magnetic field? What's going to happen? If we place them in an applied magnetic field, let's say it's going in the upward direction, we'll call it B naught. Then the magnetic fields of the protons, they could do one of two things. They can align with the external magnetic field, or they can align against it. Whenever the nuclei are aligned with the applied magnetic field, this is known as the alpha spin state. And whenever they're aligned against the external magnetic field, this is known as photons. So these protons, their magnetic field will have a magnetic field. Think of the proton that a moving charge creates its own magnetic field.
Moving charge. Creates its own magnetic field.
So you can think of the protons as generating their own magnetic field. Now, let's say if we have a sample of protons. So these protons, their magnetic field will have a random orientation. But what happens if
Daniel Carnero, are you still in the chat? Cause I was gonna refresh the chat. Okay, I'm guessing Daniel Carnero left. I really appreciate Daniel Carnero for checking out the stream. That was amazing. It's been some time since I played Undertale. So protons with a specific spin with their own magnetic field when
We take
introduced
these
to an
protons and
external
put it
magnetic field.
in an applied magnetic field. What's going to happen? If we place them in an applied magnetic field, let's say it's going in the upward direction, we'll call it B naught. Then the magnetic fields of the protons, they could do one of two things. They can align with the external magnetic field, or they can align against it. Whenever the nuclei are aligned with the applied magnetic field, this is known as the alpha spin state. And whenever they're aligned against the external magnetic field, this is known as the beta spin state. Now, as you can see, the alpha spin state is lower in energy than the beta spin state. And so the majority of the protons or the hydrogen nuclei will be in the alpha spin state because it's more stable. And what helps me to this is using the analogy of a river. It's easier to swim in the direction of the current rather than to go against it. So whenever the spin is aligned with the applied magnetic field, it's going to be in a more stable state. It's going to be lower in energy. But it's going to be harder to go against the applied magnetic field. And so it takes more energy to do that. So thus, it's in a higher energy state.
Imagine being able to build an app with your name on it. Just
Represents the difference in the energy of the alpha spin state and the beta spin state. Now, that difference in energy is dependent on the strength of the applied magnetic field. So as you increase the strength of the applied magnetic field, delta E will increase. And so you're going to have greater separation between these two lines. Now, what does it take for a hydrogen nuclei to switch from the alpha spin state? What you need is energy, particularly radio frequency energy. So if you add RF energy to a proton, and if it's the right amount of energy, it can flip from the alpha state to the beta state. Now, if the nuclei falls back from the beta state to the alpha state, it can emit radio frequency energy. But it takes radio frequency energy to promote it from the alpha state to the beta.
Alpha to beta, energy required, beta to alpha, energy emitted.
And so when it's constantly flipping back and forth, it's in resonance. Thus, we have the term nuclear magnetic resonance. So just remember that as you put energy into the hydrogen nuclei, you can promote it to the beta state. And as it falls back down, it's going to release energy. Now, if we want to, we can calculate the energy difference between the alpha state and the beta state. And here's the formula that we could use to do so. The energy difference is going to be Planck's constant times the frequency of the energy that we're going to use to put into the protons in the alpha state. Now, the frequency that we need is going to be equal to the gyromagnetic ratio divided by 2 pi times the strength of the applied magnetic field. And so you can see that delta E, the energy difference between the two states, is proportional to the applied magnetic field. Now you might be wondering, what is gamma in this particular equation? So this represents the gyromagnetic ratio of the nucleus that you're dealing with. So in the case of the hydrogen nucleus, the gyromagnetic ratio,
Gyromagnetic. H was the Planck's constant?
is going to be 2.675 times 10 to the 8 Tesla to the minus 1 times seconds to the minus 1. Now, for the carbon-13 nucleus, it's different. It's going to be 6.688 times 10 to the 7. And so it's less than that for hydrogen. So that's the formula you could use if you wish to calculate the energy difference between the alpha and the beta spin states. Now, sometimes you may need to calculate just the frequency that's needed given the strength of the applied magnetic field. And it's going to be the gyromagnetic ratio divided by 2 pi times the applied magnetic field. So you can also use this formula if needed. Now let's work on this problem. What is the operating frequency required of an H NMR spectrometer that generates a magnetic field of 11.744 Tesla? So, to calculate the operating frequency, we need to use this formula. It looks like a V, but it's really the Greek symbol nu. So nu is equal to the gyromagnetic ratio divided by 2 pi times the applied magnetic field.
I gotta go. By
Now,
the
what is
way,
the
I subbed to
gyromagnetic
your
ratio in this
subreddit.
case? Well, we can find the answer here.
I appreciate that, Daniel Carnero. I appreciate that. See
So
ya, man.
for a hydrogen nucleus, it's
I
going
really
to be
appreciate that.
2.675 times 10 to the 8 kilometer.
Wait a minute.
So for a hydrogen nucleus, it's going to be 2.675 times 10 to the 8. Now the strength of the applied magnetic field is given to us in Tesla. And so that's 11.744 Tesla. And we need to divide it by 2 pi. When typing this in your calculator, make sure to put that in parentheses. So if you type in 2.675 times 10 to the 8, and then multiply that by 11.744, and then divide that by 2 pi in parentheses, you should get this answer. At least that's what my calculator gave me. Now, we could round this answer and say it's approximately 500 million hertz. Now, looking at our answer choices, we need to convert it to megahertz. If you recall, mega is 10 to the 6. So a frequency of 1 megahertz is 1 times 10 to the 6 hertz. So you want to set this up in such a way that these units will cancel. So 500 million divided by 1 times 10 to the 6, or 1 million, is 500. So the frequency is approximately 500 megahertz. So therefore,
Finishing. Hello. Hello. What are you studying? Okay, I am looking into organic chemistry mainly, and more specifically, it's going to be NMR spectroscopy on organic chemistry. I got an exam on Friday, which is 2 days after today. Yep. And Finishang, I think I'm talking to you for the first time. I never seen this name before, if I'm right. But I really appreciate for checking out the stream. Fuck this shit, bro. Signals in HNMR. Interesting. Yeah, I don't know if that's interesting, but it's pretty, I don't know what to say. It's okay. I gotta make sure I can do this question paper on my own. That's my goal. I don't know how far I'm off from this goal, but right now I don't think I could answer every question. Maybe I could answer a question based on the configuration. My brain not braining because only in high school. Okay. Made sense. You know, when you asked me the question, I thought you were someone who was in chemistry, doing something in chemistry, but guess you're not. Well, Finisheng, what made you click on this stream?
we're going to talk about how to determine the number of signals in an H&MR spectrum for a given molecule. So let's say if we have propyl bromide, how many signals would you expect to have in an H&MR spectrum for this molecule? So what we need to do is determine the number of different types of hydrogen atoms that we have in this molecule. So let's consider the 3 hydrogen atoms.
Big brain time. I don't know about big brain, but yeah. You know, you gotta pass these fucking exams, or else they're gonna kick me out. Yeah. So I don't know if you heard the question, but what made you click the stream? Was it Undertale, or did it just pop in front of your on your homepage? And also to see if you would do Undertale. Oh my man. You know, if you made it maybe 15 or 20 minutes ago, I would have played it. But yeah, the thing is right. I play Undertale for 15 minutes. And the first person that comes to my stream, I subscribe to. Yeah. So I play Undertale for 15 minutes, and today's Undertale I already played. I'm really sorry, man. But today I was going against Undyne. This was my second day of facing the Undyne boss on Undertale. That was my progress. I did beat the boss. It's not like I beat the boss. I just avoided conflict. You could say that. You subscribed. I really appreciate you for subscribing. But you know, to keep up with the studies, I only play Undertale for 15 minutes. You win. Uh, let's just say I just avoided conflict. Yeah, I did win. Yeah, of course I win. You know, it's just big brain. You know. I don't think you see my face. I wear the shiesty because the hair is too big. Yes, I did win, if I understand. Yeah. I didn't kill Undyne. I tried to make a deal.
I found this on the web.
Should I get more people to sub? I mean, my channel is about learning, like daily studying, and 15 minutes of Undertale and Lies of P. These are the two games I play right now. So I don't know, people are interested in those, but I appreciate subs. And finishing, I really appreciate your sub. What was I thinking? I don't know if it's asking too much, but if you could make it to tomorrow's stream, we could play Undertale. We could continue the game. You know, I don't get that many people asking me to play the game. So, getting someone on the call just a minute. So, there are some people up here to prepare my wash base. That's why I just had to go. But I got you two more subs. No way. We are at 61. 61 subs. Hell yeah. I just gotta say, hell yeah. Finishing. I respect that. That's amazing. I've been sitting at 59 for a while, but now it's past 60. I feel real good. 60 people. Hell yeah.
CH3. Will they show up as one signal, or will they show up as three separate signals? Now, each of these three hydrogen atoms they have the same exact chemical environment.
Looks like we got an
They
extra
are all
viewer
attached
coming
to the
in.
same carbon atom, and they're all adjacent to this group. So
Hello.
those three hydrogen atoms are chemically equivalent, which means
I
that
really appreciate
in an
whoever
HMR
checking
spectrum,
out,
they will show up as
because
just
that
one
means a
signal.
lot.
So generally speaking, the hydrogen atoms that are attached to a particular carbon atom usually show up as one signal. Not always, but usually.
Arnasi. What?
Now, each of these three hydrogen atoms, so what we need to do is determine the number of different types of hydrogen atoms that we have in this molecule. So let's consider the three hydrogen atoms in
the metal.
CH3.
So,
Will they
Finny
show up as
Chang,
one signal, or will they show up as three separate signals? Now,
do you play any other sort of games, Finny
they
Chang?
have the same exact chemical environment.
Any other games other
They are
than
all
Undertale?
attached to the same carbon atom, and they're all adjacent to this group. So those three hydrogen atoms are chemically equivalent, which means that in an HMR spectrum, they will show up as just one signal. So generally speaking, the hydrogen atoms that are attached to a particular carbon atom usually show up as one signal. Not always, but usually. So we can call this signal A to correspond to those three hydrogen atoms. Now, these two hydrogen atoms are in a different chemical environment than these three because they're closer to the bromine atom. So they're going to show up as a different signal. And the
World of Guns. I heard the name before. Oh. It's a cross-genre simulation. It's a puzzle, okay. Interesting. That's an interesting form of video game. World of Guns.
two hydrogen atoms in the CH2, they're closest to the bromine atom. In fact, they're attached to the same carbon atom as the bromine atom. So they're going to show up as a different signal compared to the other hydrogen atoms. So for this particular molecule, we should expect three signals in the H-NMR spectrum. Now, let's try another example. Let's say if we have a molecule
Number of signals in H&MR. Spectrum. Oh Lord.
of propane. How many different signals would you expect to get from an H-NMR spectrum
Two.
in this molecule?
Two. Let's say two.
Now, what I like to do is draw a line of symmetry. Notice that the left side looks like the right side. When you see that, this tells us that the hydrogens in the methyl groups on the left and the right are equivalent. They're in the same chemical environment. Now, the CH2 hydrogens are different than the CH3 hydrogens, so we can call this signal B. So for this particular example, we should expect two different signals in the H-NMR spectrum. What about this example? Dimethyl ether. Once again, we can draw a line of symmetry in the middle. And so the methyl group on the left is identical to the methyl group on the right. So in this case, we are only going to get one signal for that molecule.
So, oh boy.
Tree.
So
We should call
it's
this
2. That was right.
signal B.
Okay.
So for this particular example, we should expect in the middle. And so the methyl. So how many signals should we get for this molecule? The first thing I like to do is identify the hydrogen atoms that are identical to each other. So looking at these 3 methyl groups, they are attached to the same carbon atom. And due to the free rotation of carbon-carbon single bonds,
I gotta download Genshin.
they are equally close to this group.
Cause
So therefore,
I heard
those
there's
3
some
signals,
offers
well, those 3 methyl groups
for
will
the
show up
game.
as one signal. So we can call it signal A. They have the exact same chemical environment. Now, everything else is going to be different. This is going to be signal B, C, and D. As you can see, these 2 CH2 groups, they're not the same. They don't have the same chemical environment. This one is close to the quaternary carbon, and this one is further away, but it's adjacent to the methyl group. This one is not adjacent to the methyl group, so they're different. Thus, we should have a total of 4 different signals. Now, let's start using line structures in our examples. So let's say we have 3 bromopentane. How many different signals should we get in this molecule? So we could say that the line of symmetry is at the 3rd carbon. And we can call this signal A because they're equidistant from the line of symmetry. And the hydrogen atoms attached to those carbons, that's going to be signal B. And there's 1 hydrogen atom attached to this carbon, which will correspond to signal C.
3.
So this particular molecule is going to have 3 signals. Try this one. 2-methylpentane. How many different signals should we get in this case? So here we have 2 methyl groups attached to this carbon. So those 2 methyl groups will be identical to each other. So that's going to be signal A. We do have a hydrogen atom attached to this tertiary carbon. And so that's going to be signal B. And then the rest are different. We really don't have a line of symmetry in this case. So all the other hydrogen atoms on the different carbon atoms will be different at the right side. Thus, we have a total of 5 signals for that molecule.
I gotta look into this once again.
Try that one.
Okay.
So for this particular example, I'm going to draw the line of symmetry here, since we have a symmetrical molecule. Now, the hydrogen atoms on those 2 carbon atoms, they're equidistant from that line of symmetry. So they're going to be identical. And then these 2 hydrogen atoms corresponding to signal B.
I got you another one.
Now, what about
Another one.
Are they identical to each other? Should we say this would be signal C and this would be signal D? Or
62.
are all 4 of them identical to each other?
Hell yeah.
It's important to understand that these 2 are definitely identical to each other because we've covered examples like that before. But also, these 2 are identical to each other. They're equidistant from that line of symmetry. They have the same exact chemical environment. And so thus all 4 of them
It's a 2016
are identical
Chinese
to each other.
account, but
So for this
hey,
particular
I don't
situation,
care.
we have a total of 3 different signals
That's
in
amazing.
the H&MR spectrum. Now what about this one?
No. Well,
Now, I'm
I
gonna
have
ask
my
you 2
ways.
questions.
Yeah, don't ask a master in disguise, right? You know, I'm not going against it. I'm happy, but That was it was finishing. I met you on a random Wednesday.
Signals should we get in the H NMR spectrum, and how many should we get in the C NMR spectrum? So let's focus on hydrogen. Now we don't have a symmetrical molecule, so there's really no line of symmetry. Nevertheless,
You know what, finishing?
these three
You
methyl
get a
groups
sub for yourself.
are identical to each other. So in the HMR spectrum, they will show up as signal A.
You got a sub.
Now these two methyl groups are identical to each other, so they will show up as signal B. Now we have a hydrogen atom on the tertiary carbon, so that's going to be signal C. And this is a CH2 group, so that's going to be signal D. Now, this particular carbon has no hydrogen atoms. So in the HMR spectrum, we should only get 4 signals. Now, we do have a carbon atom here, so I'm going to use a different color. For the C NMR spectrum, that's going to be basically signal E. So we should have a total of 5 signals in the carbon-13 NMR spectrum.
Me goes to random streamer
Now, for the
5
next
seconds
example,
later,
we're going to
gets
use
him 3
benzene.
subs, yeah?
So how many
That's so
signals
weird.
should we get in the HMR spectrum of benzene?
And
Now,
I
it's
did
important to
subscribe to
understand that
your
every
account
carbon
because
in
I
benzene
respect that.
has 1 hydrogen atom. And all 6 of these hydrogen atoms are equivalent to each other. They have the same chemical environment. So this will show up as 1 signal. Now let's change it up a bit. So instead of benzene, let's say we have bromobenzene. How many different signals should we get in the HMR spectrum?
I gotta watch this again.
And also, what about the carbon-13 NMR spectrum? So focusing on hydrogen, this will be signal A. We could draw the line of symmetry right at the center.
Stereoisomers, crystal field theory.
These 2 hydrogens, they're 1 carbon away from the bromine atom, so they have the same chemical environment. This would be signal B. They're 2 units away from the carbon with the bromine atom. And this one is 3 units away, so that's... In this video, we're going to talk about how to determine and these 2 hydrogen atoms, they will show up as just...
Finishang, have you tried playing Soulsborne games? Have you looked into those?
one signal. So generally speaking, the hydrogen atoms that are attached to a particular carbon atom usually show up as 1 signal. Not always, but usually. So we can call this
CH3, CH2, CH2, Br. Bromopentane. CH3 gives 1 signal. CH2 gives 1 signal A.
to correspond to those 3 hydrogen atoms.
No, also, you heard about the release of Hollow Knight Silksong. Yes, I did hear about those. It was pretty good, and they did somehow crash the servers. Not gonna lie, it kind of made me want to buy the game. And I heard that the Silksong is the second one. What's the name of the game that was released like recently? Wait, Silk Song is the new game. So, what's the older one? Older game? I don't know how to search it. Okay, Hollow Knight is the first one. Okay. Yeah, I saw this on Steam for a really cheap price. 14. Not gonna lie, it's pretty good. And I could buy it. Maybe after Undertale, I would buy this. This works on Apple. That's good.
Now, these two hydrogen atoms are in a different chemical environment than these three because they're closer to the bromine atom. So they're going to show up as a different signal. And these two hydrogen atoms in the CH2, they're closest to the bromine atom. In fact, they're attached to the same carbon atom as the bromine atom. So they're going to show up as a different signal compared to the other hydrogen atoms.
Oh, okay. It's gonna be 3.
So for this particular molecule, we should expect 3 signals in the H-NMR spectrum. Now, let's try another example. Let's say if we have a molecule of propane. How many different signals would you expect to get from an H-NMR spectrum in this molecule? Now, what I like to do is draw a line of symmetry. Notice that the left side looks like the right side. When you see that, this tells us that the hydrogens in the methyl groups on the left and the right are equivalent. They're in the same chemical environment. Now, the CH2 hydrogens are different than the CH3 hydrogens, so we can call this signal B. So for this particular example, we should expect 2 different signals in the H-NMR spectrum. What about this example? Dimethyl ether.
Oh, okay, I'll do it.
Once again, we can draw a line of symmetry in the middle. And so the methyl group on the left is identical to the methyl group on the right. So in this case, we are only going to get 1 signal for that molecule.
Okay.
Try this one. So how many signals should we get for this molecule? The first thing I like to do is identify the hydrogen atoms that are identical to each other. So looking at these 3 methyl groups, they are attached to the same carbon atom. And due to the free rotation of carbon-carbon single bonds, they are equally close to this group.
Okay, they still not repaired my
So
sink.
therefore, those 3 signals, well, those 3 methyl groups will show up as 1 signal. So we can call it signal A. They have the exact same chemical environment. Now, everything else is going to be different. This is going to be signal B, C, and D. As you can see, these 2 CH2 groups, they're not the same. They don't have the same chemical environment. This one is close to the coordinate.
2 signals. No, we got 111 2 3 4 4 signals. That one idiot. That's an interesting name. Quest complete, you gained a friend. Well, that's amazing. He gave you 3 subs. Aiden. Just a minute, I'm getting a call. Just a moment. Okay, that one idiot, he gave you 3 subs. That did not sound right, but hey, I'll take it. I'll take it. uh, is are all these the same person? Is it the same account? Okay, I think Finishang. No way, Finishang. Did you just change your account name? What happened to Finishang? Finishang. Finishang's gone. Now it's just an idiot. Well, that was so random, but I really appreciate that. Nah, I made an account for my brother too. Okay. But you know what? I really appreciate that. No, it makes you question. There are good people out there. There are people who support each other. And it is an interesting name. That one idiot. What a name.
Carbon. And this one is further away, but it's adjacent to the methyl group. This one is not adjacent to the methyl group, so they're different. Thus, we should have a total of 4 different signals. Now let's start using line structures in our examples. So let's say we have 3 bromopentane. How many different signals should we get in this molecule?
Oh,
So we could say
do you
that
play
one
Hollow
symmetry
Knight?
is that the third
Because if
carbon.
you do, you gotta tell me how this
We
game
can
is.
call this signal A because they're equidistant from the line of symmetry. And the hydrogen atoms attached to those carbons, that's going to be signal B. And there's one hydrogen atom attached to this carbon, which will correspond to signal
1,
C.
2.
So this particular
2.
molecule is going to have 3 signals. Try this one. 2-methylpentane.
It's not even
How many
coming up.
different signals should we get in this case?
Let me try it on my own. So you go with the Mercedes-Benz simple, then you do an opposite V. Well, I didn't play it, but I have seen the lore. There's Wiki online for that. Come on. You gotta play it. Well, I heard it's a really hard game, and that's what made me want to look into this. Hollow Knight Silk Song because it does have a Soulsborne level hardship, and you know I'm really into hard games. Oh, so that one idiot. I don't know if I mentioned this, but I do play a game called Lies of P every day. 89, 25, 28. So I guess this is 1, 2, yeah, 3, 4, 5. 5 signals?
So here we have two methyl groups attached to this carbon. So those two methyl groups will be identical to each other. So that's going to be signal A. We do have a hydrogen atom attached to this tertiary carbon. And so that's going to be signal B. And then the rest are different.
Okay, so
We
5.
really don't have a line of symmetry in this case. So all the other hydrogen atoms on the different carbon atoms will be different at the right side. Thus, we have a total of 5 signals for that molecule. Here's another one that we can work on. Try that one.
Yeah, this
So for
one
this
is
particular
easy.
example,
Easy, son. It's easy. It's fucking easy. You draw the Y. You take this down. You take those up there. You take it down. You take... And you put the draw symmetry up there. The whole thing is 1. This thing is 2. I'm gonna say 2.
I'm going to draw the line of symmetry here, since we have a symmetrical molecule. Now, the hydrogen atoms on those two carbon atoms, they're equidistant from that line of symmetry. So they're going to be identical. And then these two hydrogen atoms, corresponding to signal B, they will be identical. Now, what about the methyl groups? Are they identical to each other?
Yes. Yes,
Should
yes,
we say
yes.
this would be signal C, and this would be signal D? Or
All be signal
are
C.
all 4 of them identical to each other? It's important to understand that these two are definitely identical to each other because we've covered examples like that before. But also, these two are identical to each other. They're equidistant from that line of symmetry. They have the same exact chemical environment. And so thus all 4 of them are identical to each other. So for this particular situation, we have a total of 3 different signals in the H&R spectrum. Now what about this one?
What? 3?
In the H&R spectrum.
1, 2, 3. Okay. Oh, it's 3. I wrote 4. Okay.
Now what about this one?
Oh.
Now,
Oh. Oh, 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 oh.
two questions. How many signals should we get in the H NMR spectrum? And how many should we get in the C?
I am departing from the stream for the day. See you tomorrow. That one idiot. I will promise you, if you join the stream tomorrow, we could play Undertale. You could get the exclusive 15-minute Undertale, and tomorrow it's gonna be mostly exploration, not the boss. So if you could make it, that'd be huge. I really appreciate that one idiot for checking out the stream. Peace.
NMR spectrum. So focus on hydrogen. Now we don't have a symmetrical molecule. So really no line of symmetry. Nevertheless, these three methyl groups are identical to each other. So in the HMR spectrum, they will show up as signal A. Now these two methyl groups are identical to each other. So they will show up as signal B. Now we have a hydrogen atom on the tertiary carbon, so that's going to be signal C. And this is a CH2 group, so that's going to be signal D. Now, this particular carbon had
Okay, so similar ones. Mm-hmm.
no hydrogen atoms. So in the HMR spectrum, we should only get 4 signals. Now,
Ah. Ah. Why is this so slow now?
we do have a carbon atom here. So I'm going to use a different color. For the C NMR spectrum,
I'll be right back. Cause I gotta be right back. It's cold. Back. We're back. That one idiot. I'm gonna refresh the chat. So yeah, that's it.
as signal B. Now, we have a hydrogen atom on the tertiary carbon, so that's going to be signal C. And this is a CH2 group, so that's going to be signal D. Now, this particular carbon has no hydrogen atoms. So in the HMR spectrum, we should only get 4 signals. Now, we do have a carbon atom here. So I'm going to use the different color. For the C NMR spectrum, that's going to be basically signal E. So we should have a total of...
Let me draw this. Oh, it's same. We could draw a symmetry line. And dude, it's so cold. What is wrong with this? I'm thinking, how should I proceed? It's so cold. I'm gonna change my dress. Okay, let me just change.
So in the H&R spectrum, signal A. Now these two methyl groups are identical to each other, so they will show up as signal B. Now we have a hydrogen atom on the tertiary carbon, so that's going to be signal C, and this is a CH2 group, so that's going to be signal D. Now this particular carbon has no hydrogen atoms, so in the H our spectrum, we should only get 4 signals. We do have a carbon atom here, so I'm going to use a different color. For the C NMR spectrum, that's going to be basically signal E. So we should have a total of 5 signals. Carbon 13 NMR spectrum. Now for the next example, we're going to use benzene. So how many signals should we get in the HMR spectrum of benzene? Now it's important to understand that every carbon atom in benzene has 1 hydrogen atom.
So it's 1 signal.
And all 6 of
Or
these
3.
hydrogen atoms are equivalent to each other. They have the same chemical environment. So this will show up as 1 signal. Now let's change it up a bit. So instead of benzene, let's say we have bromobenzene. How many different signals should we get in the HMR spectrum?
4.
And also, what about the carbon 13 NMR spectrum? So focusing on hydrogen, this will be signal A. We could draw the line of symmetry right at the center. These 2 hydrogens, they're 1 carbon away from the bromine atom, so they have the same chemical environment. This would be signal B. They're 2 units away from the carbon with the bromine atom. And this one is 3 units away, so that's going to be signal C. Now, let's focus on the carbon 13 spectrum. So, the carbon atoms here are identical, just as the hydrogen atoms on them are identical. Now, these carbon atoms, they will correspond to signal B. They're identical too. And this one is different. Now, we do have a carbon atom here, but it doesn't have a hydrogen atom. So that will show up as the 4th signal in CNMR. So in the HNMR spectrum, we have 3 different signals indicated using the red color. And in blue, for CNMR, we're going to have a total of 4 signals, A, B, C, and D. So be careful if you're dealing with CNMR or HNMR. If you have a test, make sure you pay attention to this, because it can affect your answer. As you can see, the number of signals for these 2 different spectrums can be different. Now let's work on para-xylene as an example. And we're going to focus on both HNMR and CNMR. So how many HNMR signals should we get for this molecule? So let's identify all of the hydrogen atoms first. And let's also identify the line of symmetry, which is here. So these 2 will show up as signal A. Now notice that these 4 hydrogen atoms, they all have the same chemical environment. These 2 are identical to each other, And at the same time, these two are identical to each other. They're 1 unit away from the methyl group. And these two are also 1 unit away from this methyl group. So all 4 of those hydrogen atoms are identical to each other. They show up as one signal. So thus we have a total of 2 different signals in the H-NMR spectrum. Now for C-NMR, I'm going to use the color green. These 2 will show up as one signal. Now these 4 carbon atoms, they're identical to each other. So that's going to be signal B.
Okay, should be 2. I made a mistake, I made a mistake, I made a mistake.
These 2 carbon atoms, which do not have hydrogen atoms, they are identical to each other. So for C-NMR, we're going to have 3 signals as opposed to 2. Now let's try ethylbenzene for the next example.
What benzene?
Go ahead and work on that example. So let's draw the hydrogen atoms. Now, on the ring, the line of symmetry will be right in the middle. So these 2 hydrogen atoms are identical to each other. These 2 are identical to each other, but they're different from this one. These are not the same because hydrogen A is 1 unit away from the ethyl group, but hydrogen B is about 2 units away from it. This we can call hydrogen C, and D and E, because we do have hydrogen atoms on these 2 carbon atoms. So in the H-NMR spectrum, we should have a total of 5 signals. Now for C-NMR, everything is going to be the same, but we do have this carbon atom that doesn't have a hydrogen atom. So that will correspond to signal F in the C-NMR spectrum. So we should have a total of 6 for C-NMR. Now what about this one? Meta-dichlorobenzene. Try that. So let's begin by drawing the hydrogen atoms. Now, where is the line of symmetry? I would say the line of symmetry is here, between the 2 chlorine atoms. And we can see that these are identical. They're symmetric across the line of symmetry. So this is going to be signal A for H-NMR, these 2 signal B, and then this one is going to be signal C. So we should expect 3 signals in the H-NMR spectrum. Now for C-NMR, let's use a different color. We're focused on the carbon atoms, so that's going to be signal A. Here, we're going to have signal B. And then for these 2 carbon atoms, that's going to be signal C. And for this one, D. So for C-NMR, it's going to be 1 more than H-NMR due to these 2 carbon atoms, which don't have hydrogen atoms on it. Now let's work on a different example, one that doesn't involve benzene rings. So how many different signals should we expect in the H&R spectrum for that molecule? What would you say? So these two methyl groups, are they identical? Now remember, if you have a carbon-carbon double bond, there's no free rotation. So those two methyl groups are identical. They have the same exact chemical environment. This methyl group here is cis to a hydrogen atom, and it's also trans to a hydrogen atom, and it's attached to a carbon that has a methyl group. The same situation applies to this one. It's cis to this hydrogen, trans to that one, and it's attached to a carbon with another methyl group. So they have the same chemical environment. Now, these two hydrogen atoms, they also share the same chemical environment. So that will be signal B. So thus, we should get two signals for this particular molecule.
That's for H&MR.
How many signals will there be for this molecule? So we only need to focus on two hydrogen atoms. Are they identical or are they different?
Identical.
So this hydrogen is cis to a chlorine atom, and it's trans to a hydrogen atom, and it's attached to a carbon atom with another chlorine atom. The same is true for the other one. It's cis to that chlorine atom, trans to a hydrogen, and it's attached to a carbon with a chlorine atom. So therefore, they're identical. Thus, we're only going to have one signal for that molecule. Now, let's try one more example. How many different signals should we get? In the H&R spectrum for this molecule. So let's compare these two hydrogen atoms first. Are they identical or are they different? Now, this hydrogen is cis to the CH2Br group. This one is trans to it, so automatically they're different from each other. Now, this hydrogen is going to be different from any one of these two.
I gotta redraw the structure because I simplified it.
Because it's on a different carbon. It's on the same carbon as this group, whereas these two hydrogen atoms are on a different carbon than this group. So automatically, this is going to be a different hydrogen atom. Now, these two hydrogen atoms are different from the rest because they are attached to a carbon atom that is directly connected to the bromine atom, whereas all of the other hydrogen atoms are attached to a carbon that does not contain the bromine atom. So this will be signal D. Thus, for H&MR, we should expect 4 different signals. Now, for C-NMR, this carbon is different from that carbon because the first carbon has 2 hydrogen atoms attached to it. The second one only has 1. Now, the third one has 2 hydrogen atoms attached to it, but it's the only one with the bromine atom. So, in the case of C-NMR,
It's 3.
we should only get 3 signals. So that's it for this video. Now you know how to determine the number of signals in an HMR spectrum and also in a CNMR spectrum. So if you like this video, feel free to subscribe, and thanks again for watching.
Bis zu 60% auf alle Mater
We're going to talk about HMR spectroscopy. We're going to go over a few basic things like chemical shifts, spin splitting, and how to identify the right compound in a multiple choice question. And also to determine how many signals you would get in the HMR spectra if you're given a molecule. So those are the most common questions that you'll see on an exam. So we're going to focus on that. So let's go over some important chemical shifts that you just have to know for your exam.
Important chemical shifts. You know what? I gotta head to Penny to get something to eat to the grocery store. Should I be continuing after that? I guess it's better to continue after that. Let me check. Two hours 30. Yeah. I'm gonna end the stream. I'm gonna end the stream today for YouTube people. I'll be continuing later after coming back from the store and Lights of P. Peace out.